today we're going to be talking about the rule of 72, and we've done a lot of work on compound interest. This is just one more topic in compound interest. It kind of helps us give a really quick estimate of some stuff. So we're going to talk about that real fast. And this is our last topic in this unit, so that's super exciting as well. So what sometimes we want to know is how long will it take for our money to double if we have it in an investment? So when will my investment double? That's something that's kind of nice to know sometimes, right? So we use this rule of 72. Now 72 is kind of the magic number here. We need to use this number, rule of 72. It is an equation that gives an estimate. So not an exact value, but pretty close. Like it's actually pretty close for doing a very simple calculation. It gives us an estimate for how many years. This is lagging pretty hard, but that's okay. It will take an investment to double. So if you have $2, how long will it take for it to become $4? Or 10 million, how long will it take for it to become 20 million? And that's given a certain interest rate. This equation can only, notice that this is bold, it can only be used when interest is compounded annually. I'm putting a little line under that too, because it won't work if it's compounded quarterly or daily or anything else, only annually. That's when it'll work for us. And here's the formula. I'm going to put this formula, I'm going to put a star next to it because I should probably put that on my study sheet. And I'm just going to make a note that it should be compounded annually as well. So I'm going to put a star next to that as well. So a couple things. One, the interest rate needs to be as a percent. Now we've done a lot of practice changing those interest rates to decimals, but in this particular formula, it needs to be as a percent or it just won't work. So like it's just set up to be as a percent. So that's another star piece of information, has to be on there, okay? Another way we could look at this formula is sometimes we say it took 10 years for the opposite thing. So I'm also going to go interest rate equals 72 divided by years to double. I'm going to put a star next to that, and you'll notice that these two formulas are kind of just the opposite of each other. Oh, that's a weird arrow, but they're kind of just the opposite of each other, right? So it just depends on what you're looking for. If you're looking for what is the interest rate, you'd use this guy right here. If you're looking for years to double, you use this guy right here. So it just depends on what you're looking for. Both would be really, really good on a study sheet because we might need to use both. Who knows? Okay, let's give it a shot. Let's see how it goes. How many years will it take an investment of $2,200 earning 12% compounded annually to double? Now, in these questions, the double is like the key word that you're looking for, rule of 72. So when you see that word double, or even like a word like quadruple, that's the hint, because we're looking for how long does it take. Now, in rule of 72 questions, the amount of money doesn't matter. So here it said, okay, I have an investment of $2,200. I actually don't care, because if it was $2,000 or $2 million, it will take the same amount of time. It will take the same amount of time to double, no matter how much money it is. $2,000, 2 million, 20 trillion, whatever, same amount of money for it to become twice as much. So I actually don't really care about this 2,200. So I'm going to put a little X through it because it's just confusing information at this point. You know what I mean? Now, what I do need to know is I do need to know the interest rate. I'm gonna use a highlighter because yeah, why not? 12%. That's my interest rate. And it does say compounded annually, which means I'm good to go to use it. And lastly, it asks me how many years. So we have the rate, we want to know how many years. And we're good to use these formulas because it is compounded annually. So I want to know number of years. I'm going to be using this top formula here. I'm just going to write it down real fast. And it's a super simple formula, which is super nice because we've been using the compound interest formula for a while, and she's tricky, right? This one's a lot easier. 72 divided by the rate, and we leave that rate as a 12%. We leave it as the percent form right there. And then I need my calculator. So we leave it as 12%. 6 years. So if I invested this amount of money right now at 12% interest, by the way, that would be like a really good interest rate. It is compounded annually. In 6 years, however much money I put in, I have twice that much. So it's kind of like a good benchmark, just to like tell you like how quickly your money is increasing by. It's kind of what we use it as. And it's an estimate. It's not perfect, right? 6 years is like kind of a rounded number. Like it's just an estimate. Let's try another one. How many years, so again, we're looking for the same thing here. How many years will it take for an investment of $450? I actually don't care. Earning 1.5% interest. So that is my rate. It is compounded annually, so that's great. That means I can use the formula. And that's my hint that I need to use rule of 72 because it says double. I'm seeing that word double. I know it's going to be a rule of 72 question. And whenever I can find those rule of 72 questions, I'm saving myself time because rule of 72 is really quick. Compound interest is like super long. Okay, so again, we're looking for a number of years to double. So I'm going to use my formula. 72 divided by the rate. Okay, 72 divided by, and we leave it as a percent. So we leave it as 1.5%. Need my calculator. Oops. 48 years. That's a lot longer, isn't it? So I started off with not that much money, to be honest with you. I let it sit in an investment for 48 years. After 48 years, this $450 will become $900. So it'll be twice as much. Now you'll notice, the smaller the interest rate, the longer it takes. The bigger the interest rate, pretty big interest rate, the shorter it takes. And that kind of makes sense if you think about it, right? Because the more interest you're earning, well, the quicker you're going to get to your goals. The slower interest you're earning, the slower the rate, the slower it's going to take to get to your goals. Pretty reasonable. Alrighty, let's flip. Now, what we might want to do is we might want to verify our answer, like double check that this actually works out okay. And we can do that because we basically have all the information that we would normally use for compound interest. So how we would do it is we would just like use the compound interest formula that we've been using this entire time. So what this says here is if you're asked to verify or prove that this estimate is accurate or at least close, all you have to do is use the compound interest formula and calculate the investment at the end of the period. So this is the exact same thing that we just used. This was our principal, $450. Our rate, you notice we did have to change it to a decimal because, you know, that's how we do in this formula. N is 1, that's compounded annually, which we needed for this formula, and that's a 1 as well. In that example, we came up with 48 years, which is our time. And then we did the work here. So reminder, we're dividing first, then we're adding 1, then we're doing the exponent, and then we're multiplying, and you'll notice we end up with $919.57. So in example 2, we said it would take 48 years for $450 to double to $900. That's what we came up with Rule of 72. We said it would take 48 years, $450 becomes $900. When we use the formula, the compound interest formula, we see that in 48 years, $450 grows to, I should really say, $919.57. So this was our estimate. We said it would become $900. In actuality, when we do the real math, like the real long math, it actually becomes $919.57. But that's pretty close, right? Like, it would take like 47.5 years maybe to get it perfect, like be perfectly $900. If we do 48 years, just $20 more. That's not really a big difference. So this is a pretty good estimate. It is pretty close. Not exact, but that's okay. Alrighty. Now sometimes what we want to do is, like we wrote this down actually, sometimes what we want to do is we want to know if it takes this long to double, what would the interest rate be? So this is another really good formula to put on our study sheet. I already put a star next to that one, but just in case you didn't notice it before. And this will already be as a percent. So we don't have to times by 100 because it's already times by 100. So let's try it right here. What interest rate would an investment have to earn to double in 17.5 years? So there's that double, that key word that we can use Rule of 72. Notice it doesn't tell us how much this investment is because we don't care. It's good for any amount of investment. And then it says 17.5 years, and the question is what interest rate? So that's the question. This is years to double. Okay, so I'm going to use this formula right here. Interest rate equals, I'm writing the whole thing down here, 72 divided by years to double. So we're always going 72 divided by something. And in this case, we're actually going to divide by the number of years this time. So years goes on the bottom, which is 17.5. And good time for my calculator. I'm going to round it off to just, let's use 2 decimal places. Why not? 4.11. And as we noted right here, that is a percent. So I need to put that percent symbol on there because that's our unit. So if I had $1 million in an investment at 4.11% compounded annually, because that's a given, right? We have to be compounded annually. It would take 17.5 years for that money to double, to become twice as much. All right, so that's the formula. It's pretty simple. You're always going 72 divided by something, and you just have to figure out which one goes where. Like, what are we looking for is the question. Are we looking for number of years or interest rate? And we do have to make sure that interest rate is as a percent. Like, that's just kind of a, just a little detail we need to make sure we're comfortable with. Alrighty, so give this some practice and let's see how it goes. Thank you.